Welcome to Developing Graphics Frameworks with Python and OpenGL, Part 36, Extras, Axes, and Grids. In this video, you're going to learn how to create a few new meshes that will make it easier to get a sense of orientation and scale in our scenes. And those two objects, as you may have guessed, are axes and grids. The idea is that these will be objects you can just add to give you a sense of where all the directions are. We'll use red for the x-axis, green for the y-axis, and blue for the z-axis. And these will point along the positive directions in each case. And we'll also create a separate grid object. And optionally, you could set the center lines along each direction a different color. That'll give you a sense of scale. And if you want, you can add both of these together to get a really good idea of how things are spaced within your scene. All right, that being said, let's go ahead and write some code. All right, so these are the examples from the previous scene. And we'll probably use the movement rig some more in this example as well. Now that we have a movement rig, we'll probably use it all the time. But just like movement rig, these two new classes will go in the extras folder. So to begin, let's start off with the axes. They're a little bit simpler, and a lot of the things we learned when we created custom geometries and materials, well, those will be helpful here. Because, well, the axes and grids are basically custom geometries. Some very simple vertex colors and rendered with a line material. All right, in the extras folder, let's create a new file. Let's go ahead and save this one as, let's call it axes helper. This is going to help us with a set of axes. Not axis helper. Axis is plural. Axes is the plural of axis. Right, we need some imports. We'll start off with from core.mesh, import a mesh. From the geometry class, we're creating a custom geometry, right, those three axes, so we need to import the geometry class. And from the material class, these are all lines, so we're going to import line basic material. Import line basic material. All right, let's go ahead and write this. The class is named axes helper. It extends the mesh. It's going to implement both the geometry and the material that we need. I might want to think of what data we'd like to customize here. And so in the initialization function, I might want to be able to set the axis length. Maybe we'll default that to 1, and line width. I'm going to default that to 4. Not all systems accept lines rendered with width bigger than 1. So if you get some error centered around line width, you might want to change that to 1. All right, let's go ahead and create a geometry. Let's see, let's just call it geo for short. Geo is equal to geometry, and we need some position data. And really, we have 3 line segments we need to draw, each one starting at the origin. And the first one will go along the axis length, 0, 0, followed by 0, 0, 0 for the start of the second line segment. This one will run up along the y-axis. And then the last one, again starting at 0, 0, 0, goes along the z-axis. There's our position data. For the color data, you can make this customizable too if you want, but I'll just keep this simple. I'm going to use red, green, and blue for the colors. So maybe I'll just create some variables here. So red will be 1, 0, 0. Let's make green 0, 1, 0. And blue 0, 0, 1. Then for our color data, we want the first axis to be red. So both those points are mapped to red. The next 2 points correspond to green, and the last two correspond to blue. All right. Now, with that data, we're ready to set up the attributes. So let's say add attribute. Let's add a vec3. We know that these are called vertex position, pos data. Then we'll add a second attribute, also a vec3, for the variable vertex color, using color data. And then we always need to count those vertices. Right. Next, we're going to use just a line basic material to render this. So line basic material. But I do want to set some of the properties. So I'm going to put a dictionary object in here where we set what the properties are about to be. Let's see in here. I do want to use vertex colors. Right, by default we don't. So let's set that to 1 or true. Line width will be whatever the line width parameter was that was passed in. Then the line type. In this case, they're disconnected segments, which we indicate with a string segments. Right, there's our material, customized as we like it. And now, remember this class extends mesh, and we haven't called the constructor yet. The reason we haven't called the constructor is the constructor of mesh requires the geometry and material object. So now let's say super dot init, and now we'll give it the geometry and the material. That's it. That's the Axis Helper class. Right, so again, this very much follows the same pattern as when we learned about creating custom materials, custom geometries in this case. Let's say we want to add that to our scene. Right, so we've got test35 here. I'm going to make a new file, call it test36. So a new file in the main directory, I'll immediately call it test36.py. I'm going to take the code from test35, copy that and paste it over here. And we're going to add our new extra. So right now I'm in the file test36.py. From extras.axishelper, let's import axes helper. Now we just need to add some axes to the scene somewhere. Right, so let's see. I'll just add this right at the bottom. Self.scene.add axes helper. And maybe I'll make the axis length something large, right? Just so I make sure it pokes out through the pyramid. So maybe I'll make that 3. All right, let's go ahead and give this a build. Oh, cannot import axes helper. I've got the wrong capitalization right there. That autocomplete doesn't always do what I want. All right, capital A axes helper. Let's try building that again. Hey, and sure enough, you might wonder, where's the z-axis? Well, I think that's coming straight out at us. Now we can see it. And so now, kind of going up and around my scene a little bit, right? You never lose sight of where the different directions are, the x, y, and z axes. Because of the symmetry of the pyramid, in the last example, if we would have spun around and around the pyramid enough, you might forget where the x or z axes actually point. But now as you move around, you always have a good sense of orientation. You know what quadrant or octant of the scene you're actually in. Very nice. All right, so that is the axes helper object. Now at the same time, it'd be nice to get some sense of scale as well. So we're going to create a grid. And also it'll give us a sense of kind of the horizontal plane we're moving around. All right, so let's close down this example. And let's create a new class. This time we're going to go ahead and create the grid helper class. So once again, in the extras folder, let's make a new file. Let's save this one as gridhelper.py. Right, this is going to look very similar to the other class. Right, so from core.mesh, we'll import mesh. From geometry.geometry, we'll import the geometry class. And again, we're going to use line basic material. So from material.line basic material, import line basic material. All right, this class is called grid helper. It extends the mesh. Let's define the initialization function. Let's see. So we might want to say how large this grid is going to be. Maybe I'll default it to 10. So that'll go 5 out on either side. And we'll also say how many squares do you want to divide it into. By default, I'll also set that to 10. I like to keep the size and the divisions the same so I have an idea of what the unit of measurement looks like. And we'll also do a couple of colors for customizing. Let's say maybe a base grid color. Right, what color do you want those lines in the grid? So maybe I'll make those by default white color. And then to make the center lines more distinguished, let's call that center color. And I'll make that yellow by default. Of course, you can customize this however you wish. As before, we'll create a geometry object. And then we just need to start giving it some data, both position data and color data. The easiest way to do this is going to be to use some loops. Right, so first I need to create kind of a range of values. And again, the range function only takes integer inputs. Right, so I'm going to go ahead and create a decimal range of values. So I'll make that in a separate array. And there's other ways you can do this with NumPy as well. You could use the arange function, for example. But in this case, I'll say size divided by divisions. Right, and that'll give us kind of the interval or the delta between the different squares that we need to increment by. And then for n in range, how many lines am I going to need to draw? Well, for instance, if I wanted to draw 4 squares across, I'd actually need 5 lines going in each direction because of the edges. So I actually want to go in the range divisions plus 1. Values I'm going to append. Let's see, I'm going to start at negative size over 2 plus n times delta size. Right, so if the size of this grid is centered at 0, 0, by the way. So I'm going to start at negative size over 2 in one direction, and then keep going up by delta size, by increments. Right, now, with this handy little array of decimal values, we can go ahead and create the vertical lines and the horizontal lines, and add that to position data. So let's say first we'll add the vertical lines, and horizontal lines will be very similar. For each number x in the values array, let's start adding stuff to our position data. We're going to append the value. Let's see, we're going vertically, so we want to change. Oh, we should also say what direction is this plane oriented in. We're going to treat this the same way we did the rectangle class. It's going to be oriented in the XY plane. So to get it to lay horizontally, we'll need to do some rotation later. But by default, we'll orient it along X and Y. All right, so I'm going from the bottom to the top. And so for each x value, I'm going to add these 2 points. And then the color of the line is going to depend as to whether or not we're in the center. Right? So if x is exactly in the center, then what are we going to add? color data, what do I call it? Call data. Call data dot append center color. And I actually need to do that twice, right? Because each end point on the line needs to be identified with center color. And if that's not true, else color data, let's append whatever the grid color is. And again, we've got to do that twice. All right, next we want to add horizontal lines going from left to right. It's basically the same, so I'm going to go ahead and start off by copying that block of code, change vertical to horizontal. Right, so think of this as the y value. In this case, we're going from left to right. So just a few changes like so. Right, so for each of the y coordinates, start at the left and go over to the right. And once again, if we're in the middle, if y is equal to 0, then we add the center color, otherwise we add the default grid color. That populates our two arrays, position data and color data. So now we can turn those into attributes in the geometry. So geometry.add_attribute. And these are both going to be vec3s associated to vertex position is pos data. Then we'll add a second attribute. Also a vec3 associated to vertex color is call data. And as always, let's count those vertices. All right, the line material is basically the same as it was last time. Right, it's a line basic material, and I want to give it some custom properties here. In this case, I do want to use vertex colors. So we'll set that to 1. The line width. Do we specify a line width? No, we didn't really specify a line width, did we? Maybe we should. And so again, I'm going to use thick lines by default. But again, depending on whether you're using Windows or Mac, you might need to change that to a 1. So that parameter, line width, is going to be set to whatever is entered for line width. And finally, the last thing that we need to add is, well, these are going to be not joined end to end across the grid, but we want to render each one of these pairs as a separate line segment. So line type is still segments. All right, we've got the geometry set, we've got the material set, now we can initialize the mesh. So superclass init, the geometry and the material, and we should be good to go. Let's save this class, and we're going to add it to our test36.py. We need new import statement from extras.grid_helper. Import capital G grid helper. Let's go ahead and add a grid. Add a nice default grid to this scene. Now in this case, I do want to rotate the grid. By default, it's aligned with the XY plane. I'd like to have that lie along the horizontal. So I do need to store it in a variable, so I can do that. So let's create a grid helper. Let's say grid.rotate x by -pi/2, and then add it to the scene. So self.scene.add_grid. All right, that adds our grid. Now let's go ahead and build this. Hopefully we'll see a grid as well. All right, again, our first perspective isn't great, but if we rise up a little bit, we can see that grid pretty nicely. Gives us a nice sense of scale. It kind of lets us see what's going on. Pretty nice. Very cool. All right. And now that we have a sense of scale and orientation in this example, there's one more thing I'd like to do that I didn't do in the last video with Grid Helper because we didn't really have a sense of scale or orientation. I'd like to show you how to create a kind of a third-person controller here. Right, so previously we had put the camera up at this position, or we'd put the rig and attach the camera to it, moved it to this position, and do a couple of changes. Let's see, it looks like I've got a box geometry import. I do want to import a box geometry. And so what I'd like to do in this scene, a couple of changes. I'm going to take the code for the rig, and I'm going to move it down. Right, so down here, right after the mesh is created, instead of adding the camera to the rig, I'd like to add the mesh to the rig. Right, so the rig will now control the mesh. Also, I don't really need to set the position of the rig, but I do want to set the position of the camera. Right, as we just saw, if it's lying kind of at level z equals, or level y equals 0, we don't really have a very good perspective on the scene. So I'm going to add back in a line of code where we set the position of the camera. So let's raise it up into the side and pull it back a little bit. All right, so hopefully this will allow us to see a fair amount of the scene. And let's see, so I've got my camera, I've got the rig, and I've added the mesh to the rig. For the grid helper, I'm going to try making the line width a little bit thinner. I also like to make the size a bit bigger. Now let's make the size 40, and divisions also 40, just so it fills up more of our space. But I also change the line width to 1 so it doesn't become kind of a thick line blur when you go out towards the horizon. All right, giving this class a build. All right, oh, and the last thing I wanted to do is I wanted to use a box geometry. It's a little bit easier to orient what's happening with a box rather than with a pyramid. The pyramid is almost too symmetric for this example. So again, change the geometry to a box geometry, and now give the class a build. Let's take a look. All right, now what I can do in this scene, and let me go ahead and turn on my keyboard as well, and I can go ahead and move that box around. I can, have it rise and fall. I can turn it to the left and turn it to the right. Right forward on the box is this blue face right here. So I can kind of control it and move it around the scene a lot more easily. This also lets us understand what's happening with look a little bit better. When you look, you tilt up or tilt down, but that doesn't change the way you move in the scene. This box is still moving kind of along this horizontal plane, right, regardless of where it's looking. And of course, it can fly. All right, so now we have some axes and a grid to kind of orient us in the scene. And that'll be it for this example. Right, we've got a lot of really great functionality. We can do a lot with these nice basic shapes. The next topic, we're going to do a shift, and we're going to introduce another big topic next. How to apply textures or images to a surface. Right, using solid colors is great, but our scenes will look even more professional once we start applying images to them. So we'll have that to look forward to in the next set of videos. Thanks for watching.